Okay, so we'll be learning about carbohydrate clinical correlations and also your lipid clinical correlations. So these are all metabolic disorders under this topics, the carbohydrate and lipids. So we are just going to apply what we've learned from your lectures, all the theories in there, and then we're just going to learn new enzymes that are going to be deficient to a patient having this different metabolic disorders. So first, let's have your essential fructosuria. So when we talk about fructosuria, of course, it means that you have the presence of fructose in your urine. So it means that you have elevated levels of fructose in your blood, and it means that you are not well able to metabolize your fructose, since automatically what should happen in your body is for your fructose to be converted into your glucose. So the first thing that would convert your fructose uh, into glucose or any kind of metabolite that could enter your glycolysis would be your fructokinase. So as a review from our glycolysis, your fructose is being metabolized or catalyzed by your fructokinase in order for it to become fructose 1,6 phosphate, the fructose 6 phosphate specifically. So it has this pathway into which this pathway is responsible in order for us to get a metabolite from your fructose directly. So if hindi glucose ang ginkaon mo or hindi siya ma-breakdown into glucose, then your fructose could enter your glycolysis via this pathway. So it should be converted first into this one. But there are people having deficiency of your fructokinase, so therefore their fructose will just accumulate in their blood, and of course it will just go out into your urine, and luckily it's not that harmless and it's still asymptomatic. The thing is, maybe do ka uncomfortable lang sa imo ihi perme, and it kind of smells fruity. So you could eat whatever, you could still eat whatever you want since there's no dietary restriction. So next, we have what we call the hereditary fructose intolerance. So it is the same to that of your essential. It's just that in your hereditary fructose intolerance, the enzyme that we are missing would be your aldolase B. This aldolase B, again, when we look at it, we have another isoenzyme we've found in your glycolysis, or we've learned about your glycolysis. That would be your aldolase, right? So your aldolase was the one responsible into breaking down your fructose 1,6 bisphosphate into the glyceraldehyde and your dihydroacetone. So in this kind of pathway, this is also plausible if may arata sang fructose 1 phosphate coming from our fructose pathway, di ba? So this is the second part of the fructokinase. So this is the second enzyme that should metabolize the fructose 1 phosphate in order for you to directly have this one, and then of course to further input them into glycolysis in order for you to have pyruvate and other products. So with this one, there's quite a dietary restriction with this one, and it can be a severe disease, and it's also uh, autosomal. It means that of course it is hereditary. So the difference between the two is the presence or the difference between the enzymes. So next, we have your galactokinase deficiency. So when we talk about galactokinase, of course, it talks about the galactose sugar. So your galactose is also one of the sugars that we could metabolize in the body. And by the word kinase, of course, this is another enzyme that would be present in a pathway that would metabolize our galactose. So usually with your galactose kinase deficiency, you could see cataract formation. So patients usually with cataract are people having the disposition into which mostly most of these patients have galactokinase deficiency. So this is what happens in a galactokinase deficiency. So if you've taken galactose, of course, it's from your milk and other sources from your diet. So the galactokinase 1 is the one responsible into converting it again into galactose 1 phosphate. And so on and so forth, it could be further metabolized into glucose in order for it to enter our glycolysis. So sa sugod pa lang, wala na sang minaga process kay galactose. So it will just accumulate in your blood, and also it will deposit on our eyes or other pagid ng mga parts ng aton body. So that's it. So next we have the classic galactosemia. So it is still quite related to that of your galactokinase deficiency. But with this one, this is again, it will move to the second step of the galactose metabolism. So, if si first step na to ya, si galactose kinase ang wala ta, si galactokinase I mean, sa ato naman yung classical galactosemia is that the second enzyme, which is your galactose 1-phosphate, uridyl transferase, specifically siya niya ang nagka-convert ng galactose into your UTP galactose in order for it to become again your glucose. So this is the second step enzyme that you could find in your galactose metabolism. So this is what is missing, and with this also there will be again accumulation of galactose 1-phosphate and of course the galactose in your blood, resulting into this different diseases that we could see in your cataract patients. So they're quite the same into posing symptoms, but they're just different with the enzyme deficiency. Okay? So lain-lain ilang ngalan, kailan-lain ng enzyme nga nga nagakulang sa ila. So this is how a galactose is being metabolized overall. So from your galactose going to your galactose 1P, so that's the galactokinase. Here to here, for going to your glucose, you will have the uridyl transferase. So your galactokinase deficiency would be in this one, and your classical galactosemia would be in this one. But both would pose cataract formations in our patients. So if you look at it, all of our metabolisms in the body are quite connected. So from fructose to galactose, they are usually metabolized into glucose again in order for it to enter your glycolysis, or maybe they could be metabolized into different products such as your dihydroacetone, glyceraldehyde, in order for them to easily enter the glycolysis pathway. So next, we have your G6PD. So you're already familiar with this one. So with our lecture, this is just your glucose 6-phosphate dehydrogenase, and it is connected to our monohexose phosphate shunt. So in this, the glucose 6-phosphate in your glycolysis, so okay, the glucose 6-phosphate in your glycolysis, so this is the first product of your glycolysis from your glucose. So it is a shunt because this is a shortcut, or kumbaga nag-bypass ka sa sining metabolism, and to which you've used another enzyme in order for you to utilize your glucose 6-phosphate in order for us to further produce pentose sugars, and these pentose sugars will be used now for nucleotide synthesis. So if you do have G6PD, this is a newborn screening test always nga ginahimo sa mga, of course, bata kay newborn ang term. So this is always a newborn screening test. And also, if you do have this one, you have your hemolytic anemia symptoms. So it's quite X-linked trait. It means that you can get this from your mothers. Okay, so mga babae ni usually ang carriers ng G6PD. So what else? You just read all the clinical correlations. The important thing that you should remember are the enzymes missing in our metabolism. So this is how a G6PD deficiency looks like, or specifically the RBC looks quite. As you can see, these are the healthy cells. The G6PD ones are quite pale. Okay, ara. So some are quite large enough. It means that it will undergo apoptosis since they are hemolytic. So manug-pop na sila kay ga-burst na sila tungod sa G6PD ni nga deficiency. So next, we have what we call the glycogen storage diseases. So you will memorize the type 1 to 7, and frankly speaking, in my board exam, what happened is that matching type nila ang 1, ang glycogen storage disease type to the enzyme. So with your type 1, pag sa ulo ko ni guys is VP CAMT lang, VP CAMT. So that's type 1 to 7. So you memorize all the enzymes that are in here since they are really important. So again, let's just run through the different enzyme. Glucose 6-phosphatase would be the enzyme responsible into converting your glucose 6-phosphate directly into sugar in the liver. So we will look at the pathway later. Acid maltase will be the one responsible into converting your glycogen into your glucose metabolite, okay, specifically in the lysosome area. So it is a lysosomal enzyme. Next, glycogen debrancher It is the one responsible into, of course, debranching your glycogen in order for you to produce glucose again. Next, glycogen branching enzyme. So this is the one responsible into converting your glucose to glycogen in order for you, of course, to store the glycogen as storage, as a reservoir or fuel in our body. So opposite lang sila nga duwa. Next, muscle glycogen phosphorylase. This is the enzyme activating the conversion of your glycogen to your glucose in the muscle. Next, since my word nga liver, so it's the one responsible into converting glycogen to glucose or the breakdown of glycogen to glucose in your liver. So si phosphorylase, siya ning masugo kay debrancher nga, oy, debrancher, do your part, i-debranch na ko dibi kay para mahimo ka na into glucose. Diba? Kaya ang glycogen tagani, these are complicated structure of your glucose or sugars. Next is your muscle phosphofructokinase. So this is the one responsible into metabolizing our fructose 1,6-bisphosphate into their different products. Okay? So such as your glyceraldehyde and dihydroxyacetone. So all of this are all about carbohydrate metabolism, and this is the most popular or favorite topic in your board exams. So just memorize VP CAMT and all the enzymes below that. So this is how it looks like from the glycogen itself. So it's either you debranch the glycogen or you branch it in order for you to produce again glycogen, or this phosphorylase again is the one responsible into converting the glycogen into glucose. Synthase if you want the glucose to become the glycogen. So when you connect everything, so for example, you've taken lactose, your lactose will be converted into your galactose and glucose. So your galactose will be converted into galactose 1-phosphate, further into glucose 6-phosphate. So sa diri pa lang nga daan siya ning common sang halos tanan. Some would go into your pentose pathway, some will enter your glycolysis, so some will be interconverted via your glucomutase. So instead nga ara sa 6th carbon niya makadto sa 1st carbon ang phosphate, and then so on so forth, it will become the glycogen. And some also would be without oxygen would become lactate, or some will just be converted directly by the 6-phosphatase in the liver in order for us to have storage, in order for us to have levels of glucose in the blood. So this happens during emergency cases kung medyo nag-drop gulpi yung mga sugar. So if you look at it, it's so complete. So from the glycogen and everything. So you would realize nga connected lang halos tanan. So it's up to you to be looking at this different diseases under your glycogen storage. Okay? So, may mga label naman na siya, and all enzymes that has been mentioned has been discussed with its different function also. Okay? So, this is how it looks like in the liver and in the skeletal muscle. So, we both have the synthase and the phosphorylase. What happens is just that in the liver, we have what we call again the phosphatase, into which you could directly get the glucose from your glucose 6-phosphate if our sugar level drops. In our skeletal muscle, what happens in your glucose 1-phosphate is that it will be further again metabolized into your glucose 6-phosphate, but it would be led into your glycolysis pathway or the other pathways that we've seen here. Okay, so that's it. And we have the other carbohydrate metabolism disorder. So I expect you to be familiarized with the different terms. The Tay-Sachs disease, kung gangliosides na siyang accumulation. If Gaucher, glucocerebrosides. So with this one, we need memorization, okay, and familiarization, because sometimes it's being asked in the board exam. Amo lang man ni siyang mga terms nga ginausarget. So better to know this. This is from a reviewer that I've had in college. So medyo nagwa ni siya, and I hope that you would familiarize yourselves with this one. And also, we're finished. So let's go to the lipid metabolic disorders. So what happens with your lipid metabolic disorder? It's just that, again, we have what we call the condition ketoacidosis. And with your ketoacidosis, what happens in there is there sorry. is that there is accumulation of your ketone bodies in the blood. So why is it? Because again, instead of using your glucose as the fuel for energy, what happens is that we are using specifically the lipids, okay, into making energy since you've undergone starvation or not a healthy diet or maybe the keto diet kagidya. So somehow, this ketoacidosis could be caused by this factors here. So as we all know, in your lecture, what happens to the lipids? Kamo na lang bahala sang ketosis versus ketoacidosis. Read on the details. So what happens in your lipids in the body is that your lipids, okay, they undergo beta oxidation, catalyzed usually by the enzyme having the amino acid L-carnitine. So this L-carnitine will be breaking down some of your fatty acids, and what happens? It will be produced into small chains or lipot nga chain, di ba? May mga very long chain tato kag mga short chains lang. So it depends if sa peroxisomes na matabo or sa mitochondria. So next, it will be converted to acetyl-CoA, and via converting them into acetyl-CoA, they will produce the different ketone bodies that you are familiar with in our lecture, which are your acetoacetate, beta-hydroxybutyrate, and your acetone. So with this one, also we have the medium chain fatty acyl-CoA dehydrogenase deficiency. So with this one, ang matabo lang is we can't break down the fatty acid. So if we can't break down the fatty acid, of course, wala kapagid sugar, kaguay kapagid may proteins nga ginakaon. So this is the time that you would be dead, or somehow it will give you hypoglycemia since wala ka na gid sang may inug-produce nga sugar, and sudden death without timely intervention. So that would just be it for your lipid metabolic disorder. It's just all about ketoacidosis due to your lipid metabolism. You are using the fatty acid instead of your glucose via your beta oxidation. But we do also have what we call the medium chain fatty acid dehydrogenase deficiency, into which you can't break down these lipids, therefore you won't have any fuel source in the body. So it could lead to death and these conditions. Okay? So with your lipids, ang fatty acids ang tuyang undergo sang beta oxidation. And as we all know, a certain lipid could have also the glycerol areas. Diba? Triglyceride ang isa sa example sa lipids. So the glycerol could just directly enter your glycolysis. Okay, as you can see, ginahimo siya dihydroxyacetone. And then it will be converted to pyruvic acid. Pero ang ending ta permi is the acetyl-CoA. So when you look at it, again, everything is connected. So I hope that this lesson is quite clear. It's just all about familiarizing the pathways and memorizing the enzyme. So thank you for listening.